Welcome to our channel, dear students. So it is the fifth part of the fundamentals what we are dealing since 4 videos. So far, let me discuss what all we covered in previous videos. We are mainly focused on definition of a matrix, how to represent a matrix, how to count rows and columns, and then we started about types of matrices which play a vital role. Many names you going to come across, and there might be some sort of confusion which one we have to remember in what way. So to avoid such type of confusions, these video lectures will help you to remember easily. So without further delay, in continuation of that fundamentals topic under matrices, it is part 5. So do watch completely the previous video so that you get the correct content. So if you skip the videos, you may not be able to understand the continuity. So to maintain that continuity and consistency, because branch-wise videos I'm planning: matrices, probability, statistics, calculus, like that. Direct branch branch name, what all we can cover from fundamentals to uh, up to higher grade level, how to tackle the problems, how to remember, all these things will be covered in detail. So under types of matrices, it is a continuation part. In part 5, we are going to discuss here in this main video. It is seventh one. If I'm not wrong, it is seventh one, because in last video, sixth one is null matrix or zero matrix. So seventh one, scalar. Generally, scalar is the other name for a real number or a constant So for real numbers or constants, we use a simple name scalar matrix. It is seventh one. And eighth one, this is most important, diagonal matrix. And ninth one is very simple to understand, tridiagonal, because I wrote all diagonal. To avoid confusion, one more type here, tridiagonal. 7, 8, 9. So we will cover these three. Later on, some more new names you are going to get. Once all types are familiar, then we switch to on operations of matrices, how to operate with matrices. That is the main thing in under fundamentals. That will be our topic 2 then. So topic wise, fundamentals are being covered. Then you will know the grading manner. First level, second level, third level, fourth level, how you are going to get the content. That's why I request you to make a note of all the points. You can just pause the video, just retrack or recap the things. You can make a note of it so that you can able to recall what all you encountered in these videos. So you can apply the same thing and you can get better marks, or the best marks we can say. We just discuss these three: scalar matrix, diagonal matrix, and tridiagonal matrix. So seventh type, I wrote scalar matrix. For information's sake, scalar means a real number. So I'll be explaining about number system, one video under the playlist called concepts. In concepts, you'll be getting different topics there, which are very useful in arithmetic calculations, in attending entrance examination questions. All those things will be covered in that separate playlist and real number, scalar matrix. So how to remember this matrix in simple manner? Scalar. I wrote here a constant. One more name, no? One more name I gave a constant or a constant. I missed it. Constant. This word will help you to remember the matrix. Constant. Constant means fixed. It won't change. So scalar matrix, you can make use of any letter of naming. Here also only we have to consider square matrices. Base matrix will be a square matrix here. So far we are discussing only square matrix except for null matrix. Except for zero matrix, it is either rectangular or square. But here to define scalar matrix, a square matrix, simple one line of the form or type we can say, because the same thing, types of matrix of the type. So let us take one, by default I am taking A3, as usual A3, you all know, right, how to represent the matrix A here. Here what I am going to take, instead of naming all the elements, I take diagonal elements same. Diagonal elements same. Constant. But these numbers cannot be zeros. You can't take zeros. 0, 0, 0. It is not considered because it becomes null matrix later on. Along the diagonal, you should take a constant number, a constant real number. Above diagonal, zeros. Below diagonal, also zeros. Over. And I will go into insist the condition here. These elements cannot be zero. Same element which is non-zero, you have to take along the diagonal. It is called a scalar matrix. For example, A3, if I take 9, I am taking A as 9. 9, 9, 9. Remaining elements above the main diagonal, below the main diagonal, keep zeros. It is a scalar matrix. You see, diagonal elements must be a constant and cannot be zero. If you take zeros, it becomes null matrix again. So same thing, easy to remember, scalar. Next, hope it is clear to you. Just have a look on that. Eighth one, I wrote diagonal matrix. Diagonal. Very simple. The square matrix. Here also base matrix must be a square. The square matrix of the form or type. Same online or type. Now here I am going to use other letter. Instead of A, B, C, I'll take D. Our choice. You can take, because diagonal, D is very easy to remember. D for diagonal. It must be square. If I take 4, I am taking 4 here. D is a square matrix of size 4 by 4, 4 rows and 4 columns. Here, in scalar matrix, we have taken a constant real number along the diagonal. Above the main diagonal and below the main diagonal, just elements are zeros. Then that is called a scalar matrix. Scalar matrix, in some books they write constant matrix, but generally you meet that word scalar matrix. In the same way, here diagonal elements must be different. They're same, they're constant, here different. For example, if I will take small a, I take small b, small c. Above main diagonal, zeros. Below main diagonal, zeros. They are different, but all the three cannot be zero again. All the three elements cannot be zero. At least one of the three elements must be non-zero. Means you may get 0, 1, 4. Here 0 will be there, but not all at the three positions. At least, at most 1 or 2. At most 2. Because if you take here 0, these two may be non-zeros. If I take these two zeros, this must be non-zero. This must be non-zero. Be careful. I will quote an example. So here I will give the condition for the main diagonal separately, so that you can able to recall. This is the main diagonal. I wrote different letters A, B, C. Condition is that all the elements, means A, B, C. All the elements, first possibility, all the elements, that is A, B, C, not equal to 0 and different. Second possibility for ABC, at most means maximum, at most two of them, two of ABC, either A0, B0 or B0, C0, A0 or C0, one should be non-zero. At most two means out of three, maximum elements can be used is two. One element must be non-zero, either positive or negative. These two, at most two of ABC may be 0, may be equal to 0, may be equal to 0. To get the clarity on these two conditions, I will quote two different examples so that you get idea. Very simple. Just have a look of this. I'll take here D3 diagonal matrix of size 3 by 3. All three are different, but all are not zeros. Above the main diagonal, zeros. Below the main diagonal, zeros. Sometimes in short form, this we can write as DIAG, diagonal short form, open brackets. We write down the elements along the main diagonal without comma. Diag minus 4 to 9 means it is a compact form, expanded form. Here what we observe, the main diagonal elements all are non-zeros. Non-zeros means either positive or negative. 0 means exactly 0. Exactly 0. One more example I will give you to get the clarity on that. D4. Here I am going to take, you see. Here 4 is there, 4 by 4. 3. So what we observe here, the basic change. Highlight the diagonal. Above and below must be zeros. Here we found one zero entry. If it is 4 by 4, A, B, C, D, here three elements are non-zeros. One zero is admissible or two zeros admissible. Maximum three zeros can be admissible. At most three here. In this case, at most two. One less than this. How many zeros are permitted in D5? At most 4. 5 minus 1. One element among the diagonal elements must be non-zero. All cannot be zeros. If all are zeros, what will happen? It becomes null matrix. Becomes null matrix. This is about diagonal matrix. Next, we cover the ninth one, the last one, to conclude this video. Because we discussed the diagonal matrix. So to have the same idea, ninth one, try means 3. Tridiagonal matrix. Tridiagonal, 3 diagonals. 3 diagonals. So the square matrix of the form. Here also same, the square matrix of the form of the form or type, we can say. Here let us take D4. Tridiagonal means I will take T for reference. D stands for diagonal. For scalar matrix also you can take S. I wrote A there. For scalar matrix you can take S, capital S. Easy to remember. S stands for scalar matrix. D stands for diagonal matrix. T stands for tridiagonal matrix, like that. Similarly, for row matrix R, you can take. For column matrix capital C, you can take. So easy way to remember the types of matrices. For square and rectangular, you can choose anything. ID matrix capital I, null matrix O, special type. Like that. Here I took T, let us take 4. Size 4 means 4 rows and 4 columns. Here, tridiagonal. First, what I'll do, I will write down the elements. T, okay, I'll take small t, 4. Again 4. Again 4. Again 4. I hope it is completed. 4 by 4. Enclose them. So tridiagonal matrix means 3 diagonals must be there. First one, second one, third one. Highlight 3 diagonals. These diagonal elements must be non-zero, must contain non-zero elements. I already told you non-zero elements means every element either it is positive or negative. If you want to focus on zeros, at most you must take. In this diagonal, here 3 elements are there, at most 2. In this diagonal, at most 2 can be permitted to take zeros. In this, at most 3. Because at least one of the elements of the diagonal must be non-zero. If all are non-zeros, no problem. No problem. So T, because they are different numbers, I will write here T1, T2, T3, T4. Here I will take T5, T6, T7, different numbers. T8, T9, T10. So I will mention these 3 things separately. This one, and this one. The elements must be non-zero, in bracket not equal to 0, not equal to 0. And you see above and below, above the diagonal 3 elements are there, below also 3. It is possible only for square matrices. These elements must be zeros, strictly zeros. 1, 2, 3. Here also same. 1, 2, 3. Except these 3 diagonals, above the short diagonal, below the short diagonal, elements must be zeros. It is called tridiagonal. Tridiagonal. Why we have to study all these things? Because they play a vital role in spectrum analysis in chemistry. To find out the wavelengths of some sodium vapor lamp, sodium lamp, mercury lamp. What are the wavelengths? At what wavelengths we can able to get the correct light? Physical, practical application point of view, these matrices are very much helpful in programming, in diffraction. passing white light on one space of that prism, we get VBR, 7 colors on other side. All the white light colors will be split into 7 colors. To get in computer oriented way to show the same pattern, matrices play a vital role there. Their diagonal matrices play a vital role. The advantage of this tri-diagonal matrix, just remember like this for time being. In the next video, we cover some more types. Do subscribe our channel and convey this message. It is effective. It is a time saving method, and also you can refresh your memory of the concepts related to matrices so that you can perform better. Keep learning always. God bless you all.